Hey everyone, now we are going to say about encoders. Already we have discussed about multiplexers, demultiplexers. Then now we are going to say about encoders. Encoders, decoders, and then multiplexers, demultiplexers are combinational circuits. Here the encoders and multiplexers are same, decoders and demultiplexers are the same operation. Now we are going to say about encoders. What is meant by encoder? Here in encoder it has 2 power n inputs and n outputs. So here for example, if n is a 2, then 4 inputs, 2 outputs. If n is 3, 8 inputs, 3 outputs. Here the encoder output will be active for the selected input. Here the encoder performs the inverse operation of the decoder. What are the issues if more than input is active, if no inputs are active? Let us see in the next slide. There are two types of encoders are there. One is encoder and then priority encoder. Here we are going to use 4 to 2 encoder. So the inputs is 2 power 2, output is 2. The inputs we are taken as A, B, C, D and the output as Y and Z. Here, if the D is enabled, the output is 0 and 0. If the C is enabled, then the output is 0 and 1. If the B is enabled, then output is 1, 0. If A is enabled, the output is 1, 1. Here, in the encoder, it encodes the binary values as the output. Next, priority encoder. In the priority encoder, if more than one bit is active at a time, here in the previous truth table itself, we had seen the highest priority number 1 is given to the D0 means then the output is 0, 0. If it is D1 means the output is 0, 1. If more than one input is high in the input, then what will happen? Based on the priority, the bits will be active at a time. If all the bits are 0 means then the additional bit, valid bit is taken here. It is taken as D. The D is 0 if all the inputs are 0. If any one of the input is active means the D is equal to 1 here. So based on this priority, the priority encoder will works. So in encoders there is no priority bit. So based on the enable of the input, the output will comes. Here based on the priority of the input, here the MSB takes the higher precedence. If the MSB bit is high means then the output will be high. So the valid bit also high here. So here the valid bit is denoted by the letter D. If the D is high, then if more than one bits are high in the given input. So based on the value of D, it prioritizes the input value and the output will be given as based on the priority. If the here in the truth table remaining values are taken as don't care. It does not consider about the remaining bits. It consider only the MSB bit. For example, in Y0, it consider only the Y0. The remaining bits we won't consider. So the remaining bits are taken as an don't care. So it may be 0 or 1, it won't consider. So based on the priority, it will consider only the MSB bits. So the output will be given as per the input. So if all the bits are 0 means then the valid bit is 0. If all the input bits are 0 means the valid bit is 0 here. If any one of the input is high means then valid bit is 1. So based on the priority wise, it assigns the output based on the input. Then decoder. In decoder, we are going to discuss about the reverse operation of encoder. So here in encoder, we have used 2 power n inputs, n outputs. So the reverse operation here, we are going to use n inputs, 2 power n outputs. So in decoder, so n number of inputs, 2 power n number of outputs. So uh, here the n will be enabled based on the combination of the inputs. It will be active only for the one output. The remaining pins will be 0 here. So here in the input AB as taken as input, WXY is taken as output. So based on this, if this is for active high inputs, the outputs will be high based on the input value. Then here output low based on the input. Here the active low means the corresponding bits will be 0 in the output. Here we have taken n as input, 2 power n as output. Next, here 3 to 8 decoder. Here 3 inputs, 8 outputs. So here also we are using the same logic. So 3 inputs means 2 power 3 outputs. So if it is 0 0 means the y0 will be enabled. If it is 0 0 1 means y1 will be enabled. So based on the binary values, the corresponding bits in the y will be enabled. This is decoded with an example. Here we are using additional 1 bit, that is called as enable bit. If the enable bit is high means the outputs, all the outputs are will be high. If the enable bit is low means the output is, all the outputs will be 0 and the AB case will be, it is a don't care condition. If you are giving the enable bit, based on the enable bit only the output comes. So if the enable bit is high means the outputs are high. If the enable bit is low means the output also low. So based on the enable bit, here the output will appear based on the enable bits. If the enable bit is 1 here, the outputs, all the outputs will be 0 and the AB case will be, it is a don't care condition. It is an example for decoder. So we are going to implement a decoder logic for the given Boolean function. We have taken 1, 2, 3 and 7 as an function. So we are going to implement using the decoder. So already we have discussed 3 to 8 decoder, 3 inputs, 8 outputs. So based on the enable line, we are going to select the output. So 1, 3, 5, 1, 3, 1, 2, 3, 7 we taken as input and is given to the OR gate. So it is a 3 to 8 decoder. Then we are going to implement the same for the full adder. So in full adder there are 3 inputs, 2 outputs. So here the sum, what are the numbers will be valid here? 1, 2, then 4, then 7. So we have taken these values as a sum. Then we are going to connect the 1, 2, then 4, 7 to the sum and the remaining bits 3, 3, 5, 6, 7 is connected to the carry. So we have implemented the full adders for the 3 to 8 decoder. As a summary of this lecture, we have discussed what is encoder, what are two types of encoders, then decoders. In decoders, we have discussed the Boolean function implementation by using decoders. Thank you.